Hello friends. Today our video is about something uh, that is in a way both a topic which is out of the world and it is a topic which is applicable even in the atomic scale. So can you guess what I'm talking about? Yes, it is about circular motion. Today, our topic is going to be discussed with respect to a particular question, again, as I normally do for IB physics. And as I start discussing that question, you will also see how it is related to a number of concepts in IB physics. So let's see whether we can get this thing rolling. Huh? Okay, yeah. So I have got a question that I have taken from IB physics course itself, from one of the previous IB physics question, and let us see whether it can be understood properly or not. So this is again another video of upthrust, which is, in my opinion, is going to be helpful for all of you who is into IB physics, and that is going to be helpful for all of you who want to know about circular motion in a bit more detail. Okay, let's see. So our question in this case is something like this. So if you refer to the question, here we have got an object, a ball, just like the one that I showed you. It is moving along a horizontal semicircular ring. Now, if you have to find out the direction of the average force on the ball, then you have to do it by finding out the direction of acceleration. Mind you, force and acceleration, they are related to each other by Newton's second law. You know that, right? So with respect to that, we have to find out the direction of acceleration. Now, if I try to draw the direction of velocities in this question, so let's say you can understand that for the initial case, when the velocity vector when the object was at the bottommost position, the velocity vector was in this direction. Okay, and finally, when it reached the topmost position, the velocity vector is in this direction. Here, I am assuming that you know, with respect to your knowledge of mechanics, that in any case, in any motion, velocity is always tangential to the path. That is the concept that we are trying to use over here. So velocity, that's always going to be tangential to any path that we say, even if it is a curved path. So if that object is going like this along the tangent, you will have the direction of velocity. So that is how you get the direction of velocity vector. Right. So let's say in this case, the initial velocity is, let's say I name it as v1, just an example. So over here, what we are required to do is find out the difference between these two velocity vectors. So the second one, let's say that is v2. I name it as v2. Now look into this. This is interesting because both V2 and V1, they are exactly equal in magnitude. Make no mistake of it. This is an object which is moving with what is known, it is executing uniform circular motion. The uniformity lies in the fact that the speed or the magnitude of velocity is the same. But since velocity is a vector, the direction cannot be the same. It is, in this case, the direction is changing at each point of time, and since it's moving along a circle, you can understand that the direction of velocity is changing. So it's changing from v1 to v2 within this time interval that has been mentioned. Make no mistake of it. Now, if that is the case, then what we have to do actually for this question is, we have to find out the change of velocity. That is, we have to we have to find out the difference of these two vectors, and that difference has to be found out vectorially. Now, why is it that I say that? What do I mean by it? That if the difference has to be found out vectorially. So this is what we have to find out. Mind you, v2 and v1 are vectors. Now think about it. Why this is necessary? This is this is where you actually get to understand what is the difference between a vector and a scalar. Look into this. V1 and V2 are both having the same magnitude as V. Make no mistake of it. Both of them have the same magnitude of V. So if you do a normal scalar subtraction, if you just put V in place of V2 and if you put V in place of V1 as well, you do the subtraction and you will get nothing other than 0. That means there is no change of velocity. So look into what that means. If there is no change of velocity, there is no acceleration. If there is no acceleration, there is no force. But obviously, since the object is moving along a circular track, there will have to be a force, the centripetal force. You know that. So how come you get the force over here, given that there is no change of velocity? This is the change of velocity that I want to find. Now, if this has to be found out, we have to do it vectorially. Now, V2 minus V1, if that has to be done, look into this. V2 is in the leftward direction, according to the diagram, in the leftward direction. V1 is in the rightward direction. Now, if these are vectors and if you have to do a vector subtraction, then you will have to consider one to be positive, the other to be negative. Just like you consider that if along the x-axis, if it is along east, the negative x-axis is along west. So if you have a velocity which is positive because it is along east, the same velocity if it is along west, that has to be taken as negative. That same logic will apply because velocity is a vector. Had it been a scalar, we wouldn't have thought about it in that manner. So now look into this. So if that is the case, if you have to do V2 minus V1, then in this subtraction, actually we'll have to consider, we'll have to assign signs to these quantities. So let's say if I take V2 as positive, I can also take V2 as negative. It just depends on your choice. In over here, I'm just taking it as positive because of a reason that I'll explain in a moment. So if I take V2 as positive, V1 will obviously be taken as negative. So that means our expression will become something like this. Let me just try to write it and I'm sure you'll be able to understand. Yeah, look into this. Our expression becomes something like this. So I hope you understand why the negative sign in front of V1, because V2 is taken as positive, my friends. V1, which is in the opposite direction, has to be taken as negative. Here we assign the signs because these are vectors. Now, if I do it, you can understand that you will get it to be just the sum of V2 and V1. I hope you can understand that because of course negative of a negative quantity will give you a positive quantity. So that is what you will get, and that is what will give us the change of velocity. Now, the magnitude of the change of velocity was never the focus of this question. Look into this. This subtraction, you can understand that it is having the same direction as V2 and V1. Rather as V2, because when we are doing the subtraction, we are actually doing V2 minus of minus V1, and minus of minus V1 means plus V1, which means it is in the same direction as V2. What it means is that there is a net force acting in the direction of V2 because the change of velocity vector is in that direction. So if you just divide that by time, you'll get acceleration. Acceleration is in the direction of force. So this is what you will get the force to be in the direction of force to be. That is in the leftward direction. So you can understand that we have got this question. We have understood this question now, that the force would be in the leftward direction, would be in the direction of V2. But I think this answer raises more questions. The reason is, you know that in all cases, you must have seen that centripetal force, there is a force called centripetal force in circular motion, and that always acts towards the center. So if there is an object that is moving in a circular track, the force always acts towards the center. Here, you don't find that happening. What is the catch? Is there a catch? Is there something that we are missing? Well, of course it is. There is there is a subtle result that we are missing. The centripetal force or the centripetal acceleration that we know that acts towards the center, that is the instantaneous centripetal force or the instantaneous centripetal acceleration. Here, what you have found out is the average centripetal force. So, how is it that both these two are different? Remember, my friends, when you consider a complete circle, you can understand that if you try to find out the change of velocity in the same way that we did, you can find that the object that moves in a complete circle and comes back to the same point, in such a case, the change of velocity will be zero. So that means, on average, the change of velocity, since that's zero, that's zero, on average, the acceleration is also zero. So the net force, on average, is zero. But that's not true if you consider a part of the entire cycle. And that is exactly what has happened. So let me try to explain why this is the case. Now you can think of it in this manner, that instead of considering the force, if I consider the impulse that's acting on the object, it becomes easier for us to do the analysis. So let's try to do that. So let's say we have a hypothetical circular path that I'm taking. So let's say if I take it to be of this color, let's say. Now here we have the analysis from the bottommost point to the topmost point. So if I try to draw the direction of the forces for multiple positions, let's say at the bottommost point it is going to be in this direction. Okay, at other points, let's say at an intermediate point, some point over here, it's going to be in this direction. At the central point, you can understand that it's going to be in this direction, always pointing towards the center. Let's consider another point, and then I'm sure you'll be able to understand the point that I want to make. Okay, we have too many points in our discussion, but that's good, I think, because that is essentially why we are having this discussion. Okay, so if you refer to all these forces, the upward force and then all the intermediate forces, you can see that if I want to find out the impulse of the force, so for that I have to consider a small time interval uh, during which I'll have to assume the force remaining constant. So let's say somewhere over here, I assume a small time interval. Now, the impulse, you can see that it will have components both along the horizontal direction and vertical direction. The horizontal direction components, you can understand. Uh, let's say if I try to name the forces, I think that will be better. So let's say this one I name it as F1. There is another force that, let's say, I name it as F2. Okay, and F2 is the intermediate force somewhere over here. Okay, now take a look into the components. You can see that for all of them, you will have a horizontal component. But take a look. For F1, the vertical component is upward. For F2, the vertical component is downward. I am trying to refer to the component of the impulse that you get by product of force and time. So over here, if I'm trying to find out the average force acting by finding out, let's say, the area under the force time graph. If I do that, I should get the change of momentum. And from there, it is also possible for us to get acceleration, which can give us the average force acting on the object during a certain interval of time. So look into this. Over here, we get to understand that the impulse, the components of the impulse along the horizontal direction do not cancel out, but the vertical components do cancel out if I refer to only the part from the bottommost point to the topmost point. So just do a vector resolution. I'm sure you are okay with that. And this aspect of force, that why it is that in during half time period of circular motion, why is it that the average force acts toward the left? Why is it that only the horizontal part remains? Although we know that instantaneous centripetal force acts towards the center, that would be absolutely clear to you. So this is my suggestion to all of you. Whenever you're studying mechanics, whenever you're studying circular motion, please go through your previous notes on vector resolution. That is a topic that I spend a bit of time more than what I normally should, according to other teachers. But this is the reason why everything with respect to mechanics or circular motion boils down to vector resolution. and you should be absolutely clear with it in order to understand what it means. So although you can say that technically speaking, the object is not undergoing an average displacement after a complete circle, but it really is doing so under the effect of a force. So obviously you can understand that we have the case of an interesting analysis where the average force is dependent is to be found out during a particular time interval by considering the components of the impulses during the time interval, and from there we can get the clear picture. So actually, what the instantaneous picture gives you and what the average picture gives you may be completely different. So that is why sometimes in physics we refer to what is called the big picture, and sometimes we refer to the smaller picture. Both have their own pros and cons, own analysis, own areas of discussion. And in particularly IB physics, you have to be completely okay, completely clear in mind about what are their respective areas of application. So that's all that I had for today, my friends, on circular motion. I did not go much into detail of circular motion, but yes, I hope I have given you some points of thought. So if there is something that you'd like me to discuss about, something that you want to discuss about on a more one-to-one basis, yes, I'm available for that. In doing so, you can use my email ID that's given in the description box below, and then we can have a discussion. So make sure, my friends, as a suggestion, circular motion is one of the most easiest topics on in IB physics, I would say. But make sure that you have your vector resolution absolutely in place in order to understand that. So if that is in place, well, I can say that you can get the ball rolling. No problem with that. Okay, until next time, friends, that's all that I had today. Uh, Thank you for watching. Have a great